Hi, let's focus on today's topic, that is selection of like objects. Let's say I have 20 identical balls. So if I'm having 20 identical balls and I have to distribute these 20 identical balls among 5 kids. So that means 20 identical balls have to be distributed among 5 kids. Let's try to understand what happens. Let's break it down. Let's say this is going to be my some group. So I have to distribute 20 identical balls among 5 kids. So let's try to understand what happens over here. Let's take this example. If these are the objects which have to be distributed among 3 people, so what I have to do is I just have to draw 2 lines. If I draw 2 lines like this, then I can create 3 groups which will be independent of each other. So the point to be noted over here is, if I want to make 3 groups, I just require 2 lines. Let's have a look at another example. If this is the collection of objects and I have to distribute these objects among 4 kids. So if I have to distribute them among 4 kids, I'll just draw 3 lines. So if I draw 3 lines, then I'm having 1, 2, 3, 4 separate entities. So but in this question, I have to distribute 20 identical balls among 5 kids. That means I'll require four such walls or lines. The number of lines required to divide 20 would be 4. So from this 5 kids, I come to the conclusion that I'll require 4 lines or divisions. Okay, so we'll do one thing. I'll only require 4 lines or divisions in order to distribute 20 identical balls. Fine. So let's see what happens over here. I'll have 20 these objects and 4 lines. So I'm going to write down 20 plus 4 factorial. So now I'm having 24 factorial. That is, these will be the objects which I have to arrange. 20 are the identical balls and 4 are the lines or divisions. Obviously, they are also going to be identical because their sole purpose is to divide these into 5 kits. So now, since these 20 balls are identical, I'll divide it by 20 factorial to eliminate the repetitive counting of intra-permutation. That is to say, when these 20 objects will intra-permute, that won't create a new case. What happens if I have A, B? If I have 3 objects such as A, B, another case of arrangement would be interchanging these to A. But if we observe, these two A are identical. Because these two A are identical, these two cases will be exactly the same. That is the reason why we write 3 factorial divided by 2 factorial, where this denominator is 2 factorial removes the repetitive counting. So I have to divide this expression by 20 factorial. So if I divide 20 plus 4 factorial by 20 factorial, I'm eliminating all those repetitive counting when these 20 identical balls interchanged their places. But this formula counted them as separate cases, but in reality they were the same case. Now let's observe what happens to 4 lines. In case of the 4 lines, since they are also identical, if one line interchanges its place with another line, it will still be the same case. So I again have to divide it by 4 factorial. So my answer is going to be 20 plus 4 factorial divided by 20 factorial 4 factorial. Over here we observe, I can write this thing as 24 factorial divided by 20 factorial 4 factorial. So if the whole number is divided by two separate numbers such that the sum of these two numbers results in the numerator, we can see the similarity and we can use the expression, that is to write 24C4. The expansion of this will be 24 factorial upon 20 factorial 4 factorial. This thing can also be written as 24C20, since we are aware of the expression that NCR is equal to NC n minus R. Using this expression, I can write 24C4 equals 24C20. So we'll be using this in the next question. Okay, now let's analyze. If I have to arrange 15 objects, if I have to distribute 15 identical objects among 3 kids, if 15 identical objects have to be distributed among 3 kids, I'll just require 2 bars. So if I require 2 bars and there are 15 objects, so total is going to be 15 plus 2 factorial divided by 15 factorial 2 factorial. So now this can be written as 17C2, which is the same thing as 17C 15. I hope that's clear. Thank you.